And we are supposed to be live. Let me just spam this link everywhere. It's a bit too close. There we go. Da, 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 da. And I guess I could spam Twitter with this link. Do I feel lucky? No, I don't think it's time for Twitter just yet. Maybe next time. Still feel slightly camera shy, especially when live. I am just going to get started. Okay. I guess welcome back. We are continuing to write some Go code today for my little issue tracker. In case you don't know what's going on, this issue tracker is a project I have, one of way too many projects, unfortunately. And this particular project serves a few purposes, apart from just creating an issue tracker. Apart from actually making an issue tracker that they want to use because I have an opinion, some opinions on this. This was actually also my first hopefully large, CockroachDB based application, and it is generally kind of also a battlefield for testing some approaches to web development that might be unorthodox, as in I am going to be using some web frameworks that are very googly and very ivory tower. And you'll see this as we go through, but for now, let's see what we want to do today. I think today we're going to work a bit on the model, on the backend. There's currently a single CockroachDB backend. Does this show my credentials? No, it doesn't. Excellent. I think I should have checked, but I don't think I have any private code in this. This is all on GitHub. Anyway, so yes, CockroachDB backend. I currently have a database model that implements a session interface where you can do some accesses to categories and issues and comment and roll back the session. And I've already implemented yesterday some new features on the issue model, which was getting issue history. So if you scroll down, there's now, well, not scroll down this far, there's now a get history call. And this get history call just returns all issue updates. So now that we've done this, we mostly have everything we need on this model object when it comes to its calls to actually start making this accessible over gRPC. These calls are fairly low level. You are supposed to run them within a session. So for instance, if you wanted to get a consistent view of both an issue and its history, or you want to update an issue knowing that it's in a given state, you would run a few of these calls within a single session. On the other hand, the gRPC API exposes calls that are what the gRPC API consumers, so the frontend, expect the typical manipulations to be. So for instance, a get history call but augmented with the current data of the issue, or any other kind of bunch of calls in a session bundled up, and can actually inspect what I've so far designed as this protocol by inspecting proto, model proto. I have so far only specified two calls, get issues and new issue. And new issue, let's start with that. It takes a new issue request, which is the initial state of the issue, the initial comment on the issue, and who created this issue. And this just returns the ID. So this actually maps onto two things. It maps onto a new issue call, and then the comment actually, if given, becomes the first update. In the actual front end, when you will be looking at the issues, it will kind of be collapsed. Like the first comment will be collapsed onto the issue, but every single kind of text update to the issue is a history entry in itself. If I recall correctly, maybe I'm actually wrong on this. Let's see. If I look at the database, actually let's look, instead of at Go stuff, let's look at the schema. This is the issue table, and it indeed does not have a comment field. This only has really either metadata like the ID, the reporter, which doesn't change, the time of creation, which doesn't change, and then it has provisions for having the last update and the denormalized fields of the update. And the update instead contains a comment, which means that in order to implement this new issue call, we need to actually create an issue and then update it if a comment is given. I guess this is the model we're following for now. So let's do this. Service issues currently has a new issue call that just validates the issue. This is some validation code I've implemented a while ago, which does like basically sanity checks. A lot of these things, like for instance the issue type or the issue priority, are also verified by the database, but it's easier to also verify, as in it's part of the schema, that schema constraints that you, for instance, what are the different statuses or the different types or priorities. But we also want to check them before that, just for some nicer user errors, because kind of getting information, translating a failed constraint issue from a database execution into an error code is kind of painful, so we do this kind of double step. This will become slightly tricky when we're doing with database migrations that might change the allowed type, but we'll cross that bridge when we get there. For now, before we actually implement this call, let's run this, let's call this. And I just realized I don't actually have a way to run this, because if I run service model CRDB, first of all, it's gonna hopefully not rebuild the world. I need to learn to, okay, what is it complaining about? Validation go 50. Why is this not covered by tests? Oh, oh, it's you dot. No? Yeah, I guess I just never tested this code. Well, that's fun. Yeah, but if we actually attempt to run the model, you'll see it's going to complain that it's missing a bunch of certificates, because this is actually trying to use a framework that I've written for the Works of Hackerspace called HSPKI for mutual TLS authentication. But actually getting rid of this is quite easy. You do disable HSPKI or HSPKI disable. There we go. But now it is going to complain that it actually cannot connect to the Postgres database, which is funny because it's not actually Postgres, this is CockroachDB, but since CockroachDB uses the Postgres wire protocol, it looks less Postgres from Go. So if you see PQ, it actually is just leap PQ, not CockroachDB. So at this state, we have two choices. Either we actually bring up a real CockroachDB cluster, which I have in production, and we get credentials across so they can run this, or what we have done for tests, we just spin up a temporary CockroachDB instance. And I think it's actually going to be more fun if we today create a flag for the CockroachDB backend that instead of expecting to connect an external CockroachDB instance, gives you this like half testing development purposes in memory database, which is again what we do for tests. But it is also mildly useful in development, because at least me as a developer, I don't want to have to clean up a database every single time. I want to get like a clean slate. So let's indeed add some flags. Let's create a flag called flag in memory. Actually, I don't want people to accidentally run this with this flag enabled, not knowing that it's going to lose all of their data. It depends also. Let's call this flag eat my data. Boom. And flag var flag my data defined to as false, and description run CRDB against an in memory database. This will be cleared. I can only type shut down. This for development purposes only. And then, because we are good people, we are going to yell loudly. Which logging framework? Oh, I use log 15, so I don't use glog. So l dot warning with in-memory database. This will eat your data. And if we run this now, yeah, it is actually not doing what I want because I have no idea what's going on. So why is it not doing what I want? It just gets to the critical aspect. Are my levels not set right? Oh no, I'm not very smart today. I just forgot to set the flag. There we go. Yes, this will eat your data, indeed. So what we do here we try to connect to the production database, and it's, as you can tell, hard-coded to our Warsaw Hackerspace production cluster, because that's how I was testing this previously, but I don't have those credentials on this VM, so instead we'll be using the temporary database thing today. So let's first define var db, which is going to be db.connect. db.database. Up. And let's lift from tests how we are doing this test database. Guess we can just should we use this? Feels slightly odd. Tell you what. Abstract this away into no, because this will not actually compile if I just use the test function. So I guess I'm just gonna create a new function, call it db in memory database. And we also give it a cancel function, and this will also take the context. I guess we can make this use the context for cancellation instead. How do you use the context? Do we actually ever cancel the context? No, we don't. Actually, we should be taking the context from Mirko, like so. And then if we make this cancel in context, it will clean up correctly. Until this is go, we are just going to violently repeat ourselves. Could not create any memory database. And now let's actually implement find any memory database. And let's start by doing this blank. This little import blank, and just handle this lovely error handling. Lovingly handle those errors. That's what I want to say. Alright, this is some weird magic that I've done before that I really don't want to think about. But generally, that should work. Good not connect. There's no database. Alright. And now the last thing we need to do is we need to call the little cancel function we have here somewhere. Yeah, PS stop is what we need to call. So we're looking to spawn a new build routine. Yeah. Wait for the context to be done. And then PS stop. That should give us pretty nice cleanup. Alright, we need to update dependencies because Bazel. Where am I? Here am I. Here I am. Service. Come on. There we go. What is it? 44. Do I not have an error type? Oh, because I defined it here. So I need to try. I cannot do this because it's actually gonna swallow. It's actually going to swallow the error. I am told that you cannot hear much apart from my keyboard. Okay, I will speak louder and I'll check my volume again. There we go. I am sorry my keyboard is loud. I would swap for another keyboard, but it's also very loud. So, you know, what can I do? I like loud keyboards, but I guess for streaming this is not a good choice. I wonder if a lapel mic would work better. A lapel mic would work better. But this is indeed also a test stream, so thank you for your considerate comment. I will duly note it and try to figure out next time how do I make this keyboard less loud. As I was saying, I cannot just do this. I have to define the error here because otherwise the database assignment here would also become a new assignment instead of assigning to this particular database here. It's one of those things in Go you just kind of get used to with time. Has no field connect. I was told if I don't press the buttons you can hear me. Yeah, I understood that part. I was hoping by talking louder I would just talk over the keyboard, but I guess what I have to do instead is just set up some sort of time quantization system for typing or speaking, not both at the same time. It'll get time to get used to. Okay, so I call this DB. The import is called DB as well, so of course I am overwriting this name. Where did I get smashing from? Smashing. I'm going to very ambitiously call this D. And see now. No method connect. Same error here. We move the migrations into this block as well. I guess we can keep them outside. Do this here. Do this instead. Slightly cleaner. Let's see. All right. So this test server thing for CockroachDB is pretty scary because it literally just downloads. CockroachDB server and starts it, and it just hopes that it's gonna work for your architecture. It's weird. Oh, someone posted my chat. Very nice, very nice. Thank you very much. Okay, so this is now running, and that means, and it's running against the new in-memory database. Before we commit that, let's try to call this via gRPC, see it fail and say unimplemented. So the tool I want to use is called grp curl, grpc curl. I'm gonna call it grp curl, and it's literally curl for grpc. It's useful for those little debugging reasons. There's an alternative tool it's actually shipped as part of ProtoC in some distributions. That is, in my opinion, better than grp curl, but yeah, again, it's kind of painful to install, and even though grp curl is weird, I end up using this guy. And you are now going to observe how we get it. It is literally doing this. So gRPC, if for some reason you're one of those people I haven't been talking to about gRPC for the past couple of years as a huge fanboy of gRPC. gRPC is basically an RPC between processes running over the network. It aims to replace bespoke REST APIs, and compared to REST APIs, it uses an actual fixed schema. So if I were to be exposing a REST API, I could just use curl it, and the advantage of that is naturally I could just use curl. The disadvantage is that there's no fixed schema in the API, so you have to kind of pick: do you want an actual schema, or do you want ease of development? In the same definition of ease of development as if I don't have types, it's easier for me to code because it doesn't complain about types. So if you're more of a fan of Python, you might not understand why I'm so hot on gRPC, but if you like types, you might actually get it. And I religiously feel like gRPC style RPCs are the way to go. Because why not? I have opinions. So yeah, we now have grp curl. For some reason it's not in my path. No, it is in my path. And to use it, we first tell it no SSL, because by running this flag here, we have disabled TLS or SSL. Then we give it the host on which it's running and the port, just here, 4200, and then we say list, and it's gonna, because we have enabled a reflection API enhancement, is gonna actually tell us what methods are available. So this is the model service, and it has these RPCs implemented, so we can do new issue or get issues. Now without the list, it's gonna say that as yay, unimplemented, and this is actually the Go code telling you that. Same for new issued. Oh great, error. We have a messed up error message, invalid issue. Let's see. What is it? Oh, it doesn't like the W here. W is a new feature in Go for string formatting errors, and it lets you kind of define, even if you emit a string, even if you emit an error, it's gonna allow you to embed the historical information of the error, even though if you're collapsing it basically back into a string message. And apparently status errorf is not super happy with it, which I don't blame it for it. It's a pretty new feature, I think, in Go 1.13. Yeah, creator must be set. And if you were to actually pass data to this, you by default pass it in JSON format. The alternative is protobuf text format, which I actually prefer, but I forgot the flag for this. How to make it use the proto text format. I'm going to keep scrolling this until I find this. Oh yeah, dash format text. There we go. And you are going to learn the wonderful proto text format today, which is very odd. Yeah, it's complaining about the issue not set. So if we go to our little new issue here, the new issue request, first let's set the user. So it's a field called creator, and then a field inside called ID, which is a string. So we do creator, this, Now a colon, because yes, and this. And that's how you set fields in proto-text. So if you set a scalar, like if you just set scalar field, it's basically key colon value, key colon value, key colon value without commas. You just have to escape, like strings need to be encapsulated, but it knows if you terminate the string, it means a new key and a new value. It's not like JSON that this might be JavaScript. It knows that if you just finish one value, it means another key is coming. But if you want to instead say, here comes a message, another embedded message, you skip the colon and you pass it angle brackets, or you can also do this. This is, I think, a new development, and this also works, but the classic way, the OG way, is to use angle brackets. So now that we've set the creator, we set the initial state, and the initial state, so what was it complaining about? Oh, issue statement must be set. So the ID, we don't set it. The timestamp, we don't set it. Why does it have a creator here? This doesn't make sense. Let's break the API. Okay. Creator should be as part of the initial issue. Creator is not a recognized field name of issue state. It is called creator. Oh, because I didn't recompile my code, I guess. No, that should still work. I have to fix our validation code. Yep, up. There's no field or name creator. Am I looking at the right thing? What is your problem? Issue state. Is issue state different? Common issue state. Oh, I have this duplicated. What the fuck? What do they mean by this? Why do I have an issue and an issue state? Hold on. Hold on. Oh, okay. I see. I see. Oh, okay. So the original RPC kind of collapsed all these fields into that particular RPC. Huh. Yeah, I guess that makes sense. So actually there was no reason for me to do this. This was a bad choice, and I should feel bad. Let's go back in time before I started touching things. I'm also going to restore this and try to remember that I have to fix this. You can see I'm an excellent programmer. Okay. We are back in time. None of this happened. Let's reload this. Okay, so we give it the creator, initial state, and initial comment. And the creator is, because the initial state is a subset. Oh no, it's also embedded. Okay, okay, so this is basically issue state. these fields are either explicitly set or a figment of the imagination of the current or last snapshot of an issue. So basically, I remember what I meant by this. This message can come from either, like these contents come from either, like this is basically what in the issue can change. These are all the modifiable fields. And these are used at multiple points in the proto for either creation or retrieval, but other fields like the creation timestamp, the creator, and the ID are immutable, and their presence does not make sense in some context. Like for instance, issue creation, you don't know what the ID is, but in issue creation you do know who the creator is. So I split this up, and I guess it makes some sense. I was just very thoroughly confused there for a second. I was very smart when I designed this, and not very smart now. It's not issue state, it is initial state. Alright. Cool. I'm just going to give them some data. Okay, unimplemented. So this is what we have to implement. I'm going to actually create myself a little Bash script for this. Cool. So that I can repeatedly create issues on the actual running service. Oh, hi McFly. Yes, that keyboard is pretty loud. I have been told on the stream already that it is too loud. I guess I understand why my girlfriend every so often closes doors in this house. I will work on a better solution. Okay, so now that we can actually call this method, let's implement this. New issue. So what we're gonna do is we're gonna create a new session, create a new issue, and then if a new comment was requested, like if there's an initial comment, we are going to add an update, commit a transaction. This is going to give us the ID, I guess. Yes, this is going to give us the ID of the newly created issue, and then we can return that. Hopefully, let's see. SDB begin. So this creates our session, and then we defer the session to be rolled back, just in case. And what we do now is to session issues new sessions new DB issue, and we set everything that's required. So reporter is going to be rep.creator. There's nothing like having consistent names, right? Creator, reporter. That's something we'll have to change soon. Created every single time in this is a Unix nanosecond timestamp to make things easier. Last updated. So now. Title. First, no, we have validated the issue already, so we should be just able to use these fields. Famous last words. creates a new SQL-friendly structure and creates an issue from it. A new issue returns the updated issue or an error. And in the database code, I have a little system that I call an error converter that basically, given a database error, converts it to something already user-friendly, and actually something that's already a gRPC status code. So we should be able to just return this without wrapping this, because it should already be the correct format, kind of for user-friendliness purposes. Otherwise, we have the issue, and in the same transaction, we're going to session issues update issue ID and that only happens if we have a comment requested. Honk. If rec initial and we just do this. And this is, all these fields in issue update are nullable SQL fields. So if they're set, it's gonna update that particular field. If it's not set, it's just gonna not do an update on the issue. So we do do we have it? No collision. DB, let's do I already have this open? I think I was looking at this yesterday. Keep forgetting this API. Yes. db.nullString. I think it has a little helper function, doesn't it? No. Well, let's just build one. Happy little nullable string. Work, and we need to actually check class again. We should be able to just return it because it should already be a friendly error without having to wrap anything. And now we make a result. And we try to commit the session. And that should work, apart from the 20 typos I did in this. Let's see. Session issues undefined, no method issues. Because I think it's called issue, not issues. It would be nice to have this editor set up well. DB undefined. Fair enough. I don't know why go import didn't do this because no good development environment. Cannot use assignee as type string. This can be null, so we have to basically do this the ugly way. Does the validation actually take care of this? It does not. Let's do this. It's not gonna let me do that because it's a pointer. Okay, tell you what, fuck this. That's good enough. Pointer, it's this. Is it? Cool. And now I have these proto-enums that I have to convert. These are enums, aren't they? At least they're enums. So issue type is an enum, issue state, sorry, issue status is an enum, priority is not. So priority should be fine, but type needs to be, it should just work. Okay. Let's see, no method issues because again, this is issue. I think I made up this naming scheme from like the internal Kubernetes API, which honestly inside was probably a terrible idea to as an API inspiration, but whatever I was thinking at the time, we are now stuck with this. Too many arguments in call to session issue update. How did this go work? Oh, it's just part of issue update. Okay. That's right. No, it's not in the request, of course, it's in the new issue created. I should read what I delete. Undefined no, oh, because it's not database no string, it's SQL. There we go. Git compile ship it. Cool, this has created a new issue. Excellent, we are now creating issues. Very, very good, very happy. This is beginning of a great issue tracker that has no GUI, no API, no really well designed model, but hey, it can create numbered issues. Cool. I am now going to implement the other call, which is get issue. And that one is a bit fancier, so this might be a bit painful, but I think we'll manage in like half an hour at most. Get issues. How do you look like? What did I screw up here? Get issues request. Okay, so this is streaming API, so we do have to, well, it's not going to be super painful to implement because streaming APIs, streaming gRPCs in Go are fantastic. They're actually very well implemented. To try to do streaming in Python, it is honestly a shit show because kind of the whole streaming model of gRPC depends on you having a good threading runtime, and in Python it's just this weird callback thing because the whole API was designed before any sort of async stuff in Python. There's an async fork of the gRPC stub or library of something, but it's still not my favorite language to write gRPC in. But in Go it's wonderful, which you'll see in a second, as I will forget the API on how to do that and we'll check the documentation together. Because this is an adventure of me forgetting how to write code. Okay, request. Right, so we can, when given a request, we can ask for either just the issue or the issue and updates. Does that make, yeah, it does make sense because sometimes we want both, and I guess I'm thinking maybe we should generalize this even further instead of having a get. No, I think this will be fine because we can either ask for one issue by ID or a search query. Yeah, either one of those, and then the response is just a stream of issues. Stream of issues. That's how I call my life. And the stream of issues inside of it might contain updates if we so request. I guess one more thing we should specify here is how much updates do we want? And like one use of this API might be to like do a big like currently this is only by ID or by search. I can imagine being like by batch. We'll see what I'm doing with this in a second. And if you do that, there'll be a repeated in 64 IDs. And then we might want to specify the number of updates we want per issue instead of a just global limit and offset. But honestly, this is such a generic API that I guess it will be fine with just having an extra field here at the... I'm breaking the API backwards compatibility by renaming those fields, remaining those fields, but it's fine. Trust me, nobody uses this. So we can add here len64 that says that's called update count. If yeah, we're basically going to define this as a generic high-level call for when you want to get like a list of issues to render in the front end, and that might return, I guess, I'm confused. I guess this is one of those things that makes sense to first actually write the client for this instead of trying to make up an API, because it's very easy to just implement APIs that nobody will use, or implement APIs that you'll then be working against, working around in the front end. Like for now, I just want to have a very generic. So the problem is, like, we cannot guarantee that we'll return all the issues here, because this is a streaming API, and that means we can return multiple issues, basically keep returning them forever, like millions of them. However, each issue must fit in a single gRPC message. And those are limited to, I think, 4 megabytes by default. So technically large issues might, if you request all updates and in your update stream you have an issue that has a ton of comments, this can get truncated against your will. So technically a more robust API would be to return updates as a stream as well. But I don't want to turn this API into such an API. And I feel bad about implementing like a half-assed, like what is the point of retrieving issue updates here? Will we ever need to retrieve multiple issues and then need some updates but not all of them? I guess not really. Like we'll be listing issues in like a table view, and then when you drill down into an issue, then it will just care about that particular issue that you're seeing. And for search, this will be a totally different API. It won't just be, give me all the issues and, do a linear search on the front end. That's silly. There will be like a server-side search. What else could this be used for? Yeah, I guess we can just, fuck it. We never return updates. That's it, problem solved. Just the issue. There. And if someone wants the updates, we'll create a new RPC in a second. Simplify, and make your life easier. I think that's how we're gonna do about this. But before we continue this, I am going to take a quick 2-minute break because I want to air this room. My CO2 meter is going haywire and I might fill up my water glass. So I'll be back in 2 minutes or so. We are back. That was faster than I hoped. Well, than I planned. I hoped it'd be even faster. Open the window and I tell you, one of those small CO2 meters you can get off Amazon for like $30 is priceless. It will angrily show you, light you a red LED when you're getting dumber because of the amount of CO2 in your room. And really, when you're speaking, when you're talking to a camera, when you're in meetings, even if you're not in a room full of people, when you're just at home on a Zoom or Hangouts or whatever call, you will exhale more CO2 from my experience, or at least towards your CO2 meter. So open up your windows, get yourself one of those CO2 meters. It's gonna tell you when you're dumb because of just a lack of oxygen versus just when you're usually dumb like I am. Speaking of dumb, let's go back to this project. So we simplified this API request. And now that we have done that, we can go ahead and quickly implement it. All right. So the first thing we're going to do, we are going to cheat and only implement returning by ID. And this is one of those things in gRPC that I always have to look up because you'll see this has a one-off clause here, and it means that only one of these fields can be set, and I never remember the generate API for this. So we'll find this out in a second. Proto go generated. This is a very useful document because it just shows you, given your schema, what is the generated Go code. You basically have this document for every language that Proto supports. And especially when you're writing in dynamic languages where you can't ask your editor, or when you're like me and you haven't set up your editor to give you code completion, this is an invaluable reference because it's either that or just reading the source code of the generated gRPC stubs, Proto stubs. And you see here, this sample message called profile has two fields, image URL, image data, part of a single avatar clause. And in the generated code, you have a magical field of type avatar called is profile avatar. No, I'm sorry, yes, this is the type name, this is the field name. And it can take either one of these structs that are generated. These are not, like this will generate a struct for each one of those fields, even if one of those fields is a scalar. So you see that string and bytes are scalars, at least in Go proto parlance. So we just assign them, like it still generates them a struct. So if this is a message instead of just a string or an int, it's gonna give you a lot of nested structs, which is slightly unwieldy, but we get used to it. And the way you use this in Go to check whichever one is set, you basically do a type assertion. And the way you do this in Go is switch query type assertion to std model get issues request by ID, and the name comes from the field name. That should be this. And here we're gonna handle it. And otherwise, we just error out. Is this not how this works? What's the next one? Go switch type set. Alright, we do this here. So we do like that. And like this. And we don't really need the inner, but how do we? The proper way to be like do then get as.get issues by ID. Yeah, let's do this the last way. And let's just copy paste all of this. And it's actually one issue, so we can already name this properly. And we should reach the scope path. We are going to write tests for this at some point, don't you worry. Cannot have dynamic type missing. What? Okay. Why did I mess up? Let's look at the supposed generated code. It's a pointer that it wants in the type. Oh, I know. This is a fun one. I've had this issue before. So the problem is that we have this by ID message here, and model get issues request underscore by ID is actually this message and not this magical type that's generated for this one-off. And if I recall correctly, that's how it's generated if there's a collision. Yeah. I think that solved our problem. Again, the issue is that for a one-off, it will use the name here to create a type. And it's gonna convert this to the camel case signature, camel case naming scheme. So this would be by ID, capital B, capital I, underscore. The problem is that within this message we already have a message type. Like within this message, we have this message type that has a colliding name. So in this case, proto-C will basically add an underscore. The first time I hit this was slightly painful. But one of those things you learn. It is like one of those things that actually make you slightly upset at Go and at Proto, but it's good enough. And instead of this, it's just going to accept the inner type. So spb.id. What is it? All right. Model request. Yeah, full type name. And again, oh no, because now it's actually inner dot by ID. Something like this. Is this gonna work? Yeah, this is gonna work. So because this is this generates a struct and that contains this struct inside. It is weird. It is slightly weird. Anyway, now we have the new issue, and now if we get issues, unimplemented query type nil, comment text the ID many arguments. Too many arguments. So this is one of those things about GRP curl that you have to specify arguments in the right order. It's not smart enough to shuffle them around. Okay, unimplemented nah. It's exactly the code path we wanted to reach here. Cool, fighting with types. It's like Haskell, but a much worse type system. Cool. So what we do now is we basically do the same thing. Create a session. Actually, we don't even have to create a session. This is where the auto sessions come in handy. There is a mechanism where you, instead of doing begin, you do on the context, which we get from serve sol, and then issue get right. Again, these are friendly types to return. And now we just have to convert the type. So we are going to write a little helper thing here for ourselves. Instead of just converting the database issue and the proto issue here, we are going to do this once and for good in db issue. And let's open proto definition. Hopefully in the same screen. Oh, in the screen you want. Come on, I saved you. Did I? I did. Cool. So this issue, this database issue maps into basically this message in the protobuf. All the fields are there, so we should be able to write a little helper function here. Proto that returns SPB issue. I guess common PB issue. And we are just, if there was an error converting, I guess we could. What do we do if there was an error converting the database? I guess we return nil and we let the caller figure this out, because we as a converter function have no idea what the error should it actually be. Is it data corruption? Is it unavailable? Is it like a schema migration issue? So let's just return nil if there was an error converting, and the caller will have to figure out. And we're just gonna hide away what was the conversion issue. There was a conversion issue. This might bite us at some point. Should be good for now. We don't even have to convert this to the Go time type, because we are using nanos both in the proto and in the schema. That's cool. Creator. I'm going to replace creator with reporter. I think reporter is a better name. Updates is going to be nil, so we can skip it, and then issue our current is going to be CB state. Oh, this is a user that I have to do CPD user ID. Not sure I like those nested types that much, like the having defined user and timestamp might be a bit too over-engineered, but we'll see soon. Like, especially with all the user stuff, I'm really not sure how the authentication layer is gonna look like for this yet. I have a vague idea, but we'll cross that bridge when we get there. I'm not thinking too much about this for now. This is not user, this is we do not implement CC lists on the database yet. Like there is a table created for CC lists, basically you know who is subscribed to this issue, but they're not really being populated yet. So I guess we can add a to-do. Let's see, it's built. Okay, I'll this out. Okay, has no title with capital T-I. Typo. Too few values in common user. Right, because we need to actually specify the ID. A non-field type. In a non-field type instruct literal type common issue. Oh, because all of these go here. Missing return at end of function. That is in service issues. Cool. So we have this little conversion routine which we should also test at some point. And in this case, if we fail to convert, we are going to return. So gRPC has a set of typical error codes, which are very useful for distributed systems. gRPC status list. They might not be what you want for other kinds of applications, but it is generally a pretty well-defined set of issues for like you know, distributed system use. And I don't want this, I actually want this. I prefer this documentation. And it's in the codes. There we go. So all of these are codes for gRPC. And in this case we are going to return not data loss. Data loss will be returned by some sort of housekeeping routine that runs every so often and ensures database consistency, if anything. Or maybe it should actually return data corruption or data loss. Because this is painful to handle on the client side. It's not an unavailable because we should not the client should not retry. Failed precondition is kind of Or we can do internal. See, you can spend so much time just deciding on the error code. I'm going to return internal here. I usually don't like returning internal, but I think this is good enough. What do we tell the client here? Issue database, no, database and pay for issue first. And it's kind of generic, but so do. Otherwise, if we were able to retrieve it, we just do serve. This is a streaming call, so we don't return it, we just do serve send issue proto. Because if this is like a return by search or return by batch, it's going to basically call serve as many times as it needs. Yeah, it does serve send once, that returns an error which we just return. Let's see. Issue not found. Let's create one. So we put it now. Cool. We have successfully retrieved the issue. We cannot update it yet, but hey, that works. Create another one. It's going to be the exact same issue, just with a different ID and a different timestamp. Cool, that works. I'm going to commit this now. Let's review this quickly. We have gotten rid of the return type, we have specified this, we have documented this, build file changes. We should have committed the database as a separate commit, and actually we are going to still do that. Should have committed earlier. Now we have to hope that this does not these do not overlap, so that we can just submit different files and different commits. If I were to use the right file name, and in CRDB Go we only implement the in-memory database. Files. And this is just the service implementation. Okay, cool. First commit. Service model CRDB. Alright. First commit. And then the rest should be fine as well. Let's see. This is the validation bug we fixed. For some reason wasn't getting compiled when testing. Cool. Issue status is not there. Cool. I'm going to push this off and only now start writing tests because we are not responsible. We don't even have a test framework for the service, do we? We do not. Oh, fun. Do we make a test harness, a test system for the entire service now? How do we all feel about this? I don't feel like writing unit tests that much, but I also don't feel like writing a test for all of this as a single unit. It feels basically just repeating a lot of the database tests. Good question. I feel bad not having this tested at all. There is some logic in the service code. There's not much of it, but there still is some, like all the proto-parsing, switching behaviors based on set fields, etc. should be tested. Probably more than the type conversions even. The only problem with, like, the reason I don't want to write this now is that if we weren't to have any streaming RPC calls in the basically object that implements the service, we could very easily write tests, because you literally just call it as if you were talking to something on the other end of the wire. Like, it's the same API for the client and for the server. However, if we have streaming RPCs, like again the get issues, creating this serve object in tests is not super fun. Like, it's not actually a very well designed flow. And last time I wrote tests like this, I actually ended up just spawning an actual gRPC server with, like, on a temporary socket and connecting to it this way, which I find slightly ugly in a way as well. And maybe McFly is right, maybe we don't need tests. Maybe the key to salvation is trust in our own code and enough chutzpah to feel like we don't need to test this. I feel like also maybe writing something a bit more exciting than tests for this stream. We could technically try to already pipe this to the front end. Like, there is an little HTML front end, and we could try to render something. But for that we'd have to extend also the get issues call to let us return issues that we want to render by default. So my idea was to have basically everything be search based for actually retrieving issues, instead of implementing those other one-offs for different type of queries, like, I don't know, return all issues assigned to me, or all issues in this component, or all issues with this this other assignee, or created by this person, or with this priority, or even like a more complex query. Actually have some sort of like text filter based system ingrained quite strongly in this, and have this same filter system be basically what the user uses. As in, for an example, one of those queries could be just foo, which would be a plain text search of everything. When in this case we would need to use some sort of indexing system for this. That's a discussion for yet another day, like how do we actually do search in this? Because CockroachDB doesn't even really have full text search like Postgres does. So, knee-jerk reaction, maybe use Elasticsearch or something, but I really don't want to have an entire Elasticsearch instance as a dependency of this. So maybe have like a smaller, like a simpler version of this that is written in plain Go and scans the database, because scanning the database should be enough for thousands of issues. Like, it should be fast enough to just scan and maybe do some parsing of the query. A middle ground solution is to actually write an indexer in Go and have a little service hanging off the side that regularly indexes the issues and builds its own like bespoke index of entries for full text search. There's like a bunch. I'm aware of one or two. Believe this thing that we could use to write a little service for indexing and for searching issues. Yeah, I'm not sure. Maybe actually implementing search should be fun now. Maybe not now, it is getting late, but as a next step, implementing search should be cool. Because I do understand that Elasticsearch should be an option, but I really don't want it to be as a bare dependency for this. Like, the idea of this whole issue tracker is that it should scale from your small project, your startup, to basically thousands of users. And I think this should work. Of course, I haven't benchmarked it because CockroachDB is actually quite fast, and the way I wrote the schema and the way I'm aware how CockroachDB works, this should scale quite well. But for search, there's basically no one size fits all solution. We do have to implement something that's swappable between small and large deployments. So if the search was just like let's say the string was like one of the format I want to implement is title bar and assignee me, or q3k, and also, but in addition to that, it should also have like both formats, both key-based entries and full text search. And full text search in the same query. And if it was just those parts, that should be quite straightforward. Not easy, but somewhat straightforward to translate to database queries. Like we just write something that generates a query, translating keys to table name to column names, and making everything nice. But for full text search, even for this we still need some sort of index on the tables, because we don't want to scan. And another reason we want to have full text search, I think, instead of just exact value search. For like fuzzy search would be nice, because then you can have auto-completion. Like you start typing something and you immediately get suggestions that, oh, you typed, I don't know, Postgres in your search bar, and then you get a bunch of solutions auto-assigned, or auto-completed with like context, so that you know how to search further. So I really want this to be a first-class search, and I have no idea how to write search. Like I might have worked at Google, but I was very far removed from the search team, and I have no idea how to do any of this. So I might go again with McFly's recommendation of cutting it short today. Well, short, it's already past midnight. And scheduling some other time where we go ahead and implement this properly, and I have a good time to think about possible approaches, and we explore them together next time, and maybe prototype something. Yeah, and until then I'll also try to figure out some of the technicalities, maybe get a better microphone and a pop filter, if I manage to get everything shipped, and figure out a way to make the keyboard quieter. I do have another keyboard and it has technically quieter switches, but I just need to record both and compare and see if it makes sense to actually swap any of them. So I do think a break by now is a good choice. Yeah, no need to dwell anymore on that. I thank you for joining in today. I hope this wasn't too boring. I guess it was, because the reason I even streamed this in the first place, to get a little bit less bored when writing this myself. And that is what I'm using all of you for, to make me stop switching immediately into Reddit or IRC, and instead actually get some small amount of work done. Those RPC calls weren't super interesting, but search should be, so tune in next time when we work on search. And again, thank you for your time, and see you some other day.